Hello YouTube and welcome to your first Geek Trip. Today, we'll be strolling down the 3D printer lane with my review of the Monoprice Maker Select, an inexpensive 3D printer with tons of features. But is it too good to be true? Take the trip with me, Tripp, and find out. So I'm sure most of you have heard of or seen a 3D printer by now. But for those who haven't, 3D printing is an additive manufacturing process. The Maker Select is part of the most popular and cost-effective 3D printers known as FFF or FDM, which basically means it melts plastic and layers it on top of each other to make a 3D printed object. What's really cool is that you can thank an open source community known as the RepRap community for bringing these really low cost 3D printers to the market. Because before that, it was really only aimed towards business because the pricing was up there, $50,000, $100,000 machines. And it was because of the RepRap community that you can now buy a consumer much lower cost 3D printer. Nicely enough, the Maker Select is actually based off of one of these printers known as the Prusa i3. So onto the Maker Select itself. The design is pretty much a reskin of the Wanhao Duplicator i3. The Maker Select comes pre-assembled and is constructed out of steel as opposed to the much weaker and prone to warping acrylic of other entry-level i3s. The Select also comes with a decent build volume of roughly 8 inches by 8 inches by 7 inches, or 200 by 200 by 180 millimeters for our metric friends. It also includes a heated build platform to lower warping on high temperature plastics, and all of this is for a simple $350 with free shipping in the US. I know what you're thinking. This thing sucks for $350, huh? Well, rhyming aside, not necessarily. With price in mind, it really is quite an impressive printer. It isn't going to print perfectly right out of the box. You definitely need to do quite a bit of tinkering to get the build platform just right, and you're going to have to do it more than once every few prints. And thanks to the screws, you've got to hold the top while turning the nut, or the whole screw turns with it, doing nothing in the process. But once you've done that, if you're printing in PLA, the prints are going to come out excellent. With that said, I interjected the whole if printing in PLA part for, unfortunately, there were two things I had to do to get it working with higher temperature plastics like PET. For starters, I had to switch out the hot end because the original MK10 with the PTFE tubing couldn't go past 230 degrees Celsius. Luckily, there's a very simple upgraded hot end by MicroSwiss that makes your MK10 all metal for higher temperatures. I'll link to that in the description below. Sadly, that wasn't the only problem with high temperature prints. After replacing the hot end and beginning to print with PET, I found parts of the layers not sticking properly. So there'd be tons of strings randomly curling up. To top it off, blobs would periodically get dispensed in the print, which just made no sense to me. I tried asking around, but I couldn't find much. I eventually chalked it up to PET being difficult to print, but one day it hit me. I remembered seeing the LCD display the temperature fluctuating quite a bit during one of the prints. It would shoot up around 10 degrees in a split second and right back down the next. I didn't think much of it at the time because fluctuations can occur, but it's usually only a degree or two. Either way, it all made sense during my realization. At times, the extruder was getting too low of a temperature because it thought it was much higher. This led to extruding material too cold, so it would do one of two things, either not fuse well to the lower layer or not allow any to extrude for a few seconds until the temperature went back up and caused a ball of materials to come out. So now I knew my cause. But what was the answer? I quickly found this to be a pretty big issue for many. After calibrating the PID, I realized it wasn't that. So after further looking, pages later on the same thread that is, that it was actually the grounding of the extruder from the board. They suggested 2 different locations to solder new points to the power's ground. I eventually got it open and did the first suggestion of soldering the extruder to the negative power line as seen here. And to my surprise, it greatly dropped the influx from 10 degrees to about 5. I was told the second solder would lower it even more, but I wanted to try with a smaller influx before messing with the board anymore. And it worked. It was a small enough difference, and it moved back and forth much quicker. The influx of 4, it was about 4 degrees. It moved much quicker, up and down, up and down, up and down. So it corrected the temperature fast enough that it didn't lower the temp too far. It was printing beautifully. Another gripe I have is with the board itself. I fully understand this particular board was used to cut costs, but please be aware that without switching the board out, you're not going to be making many upgrades. The board is called a Mitsu board, and it's really just made to give you exactly what you need and not much more. So maybe all of that was a long-winded. This printer can print with some of the best of them, but don't expect plug and play in this price range. It just isn't going to happen. But for $350, this is definitely an excellent option that most of you should certainly look at.